Hi, my name is Theo, and this is the analog oscillator. This circuit consists of two 1Ks, two 10Ks, two 100 microfarad capacitors, two 5mm yellow LEDs, two 304 transistors, and a single pole double throw switch. Since this is the PCB version, there's also a 3 terminal blocks and 1 power jack. This is how it looks when it's turned on. This circuit is also known as an astable multivibrator due to its lack of a stable state. This is evidenced by the constant oscillation between both LEDs. So without further ado, let's dissect this circuit. When taking a look at the project schematic, a key thing to notice is that the right half is a mirror of the left half. Now current flows through the positive terminal through the LED and to the capacitor and the collector lead of the first transistor. As the capacitor fills up, current flows through it into the base of the other transistor. The same goes for the reflection until current is applied through the whole circuit. The reason the oscillation occurs between these two LEDs is due to the charging and discharging of capacitors, which is what lights up the LEDs. This lack of a stable state can be compared to the monostable multivibrator, which only has one stable state, hence the name. Taking a look at the monostable multivibrator, we see that the one stable state is when the LED is off. This can be explained by the fact that when the button isn't being pressed, the capacitor is filling up. And as it is pressed, it is discharged power using all of its energy to power this LED. The amount of time it takes for the capacitor to charge can be calculated as 5t or 5 tau, where tau is equal to the resistance times the capacitance. In the case of the analog oscillator, T is equal to 1 k ohms times 100 microfarads equals 0.1, giving the capacitor a total discharge time of 0.5 seconds. Of course, the math would be useless if it doesn't translate to the actual circuit, but this can be tested, and as expected, it does align with the math. This was the analog oscillator. My name is Theo, and thank you for listening.